Hello everyone, we are the group 1 will be presenting to you our final project on the subject of BCA182 Embedded Systems Programming regarding keypad interfacing. Now we have two different projects, the soil moisture sensor and the keypad interfacing. However, for our group will be presenting to you the project that's related to under the category of keypad interfacing. In this project, we'll be following the program by Smith in his book on regarding security code using keypad interfacing. However, in his book, his program is about you input the numbers like 135 or 097, the one LED will turn on, and if you repeat the same numbers, it will then turn off. That's only for one LED. However, for our group, we will try we have achieved 3 LEDs. However, the difference with our program, with our concept from Smith is that if we enter the first 3 numbers correctly, the red LED will turn on, and if we enter the second 3 numbers, the yellow LED turns on, and then if we enter the third 3 numbers correct, third batch of 3 numbers correctly, the green LED turns on, and then we will press the 0 key of the keypad to end as a form of enter, and then the green LED turns off, and it is a some kind. It tells us that you have correctly entered the correct security code, and you're now entering the secured entrance. Now this is our schematic diagram. We're using the PIC microcontroller PIC16F877A. We're connecting the 3 LEDs to port A. Red LED is connected to the pin 0, then the yellow one to pin 1, and then the third one is to pin 2. However, for our keypad, it is connected to port B. Column 1 here, particularly number 1 here, is connected to pin 0 of port B. Column 2 to column 1 connected to pin 0, column 2 to pin 1, and then column 3 to pin 2. And then row 1 is connected to this letter A. This is row 1 connected to pin 3, and pin 4, pin 5, and pin 6. For program, first we will be declaring some SFRs, 0 bit, which is located at address 2, TMR 0, timer at 1, status at 3, and port will be also declaring using port A and port B, so as trace A and trace B. Port A and port B are located at bank 0, addresses 5 and 6, while trace A and trace B are bank 1, address 85H and 86H. Option _R, 81H. Then we'll also be using num1 up to num3, which we took from 0CH, 0DH, and 0EH addresses. Then since we're using P16F877A, so we're using this code list P equals 16F877A. Then to start the address in the memory, which is 0, so we use org 0, then go to start. We have also a subroutine section before we start the program. It is to scan, then no operation. It is used to scan the keypad, and then it's followed by the keypad itself. So column 1, which is is this. We need to clear port B0, which is 0, which is this. B0, pin 0, port B0, then port B, then set port B1 and port B2. Then we're going to check if port B3 is clear. If it is clear, we call delay P1. If not, we go to check 4, which is to check if port B4 is clear, meaning port B4, that is the second row. If it is clear, then we call delay again and then go to check for A. However, returning here, if check 1 is clear, if the port B3, I mean row 1, this is located at pin 3 of port B. Row 1 is, if it is clear, then you proceed to, you call delay, which is, this is delay P1 is to clear your TMR0, and proceed with the loop D to move the file of TMR0 to the working register. Then we have time -3, and we will check whether time minus the working register is clear. If it's 0, if it is clear, if it is set, we will return. That means the time is 3/32 delay, and we will return. Or else we go back to loop D again. Repeat the process until we have this value 3. However, we return here. Column 1, check 1. If it is clear, yes, call delay 1. Then we check 1A. We proceed to check 1A to see if port B3, this one is set. If it is set, we call delay B1. We call delay and then return the value of 1 to the working register. Else we go to check 1A, which is this, to repeat the process until port B3 is set. Same is true for the other rows and columns. You see, like same is true with the other rows, like check 4. If it is clear, then we go call delay and then proceed with check 4A. Is set, then we go to check 4. If it is set, we skip this, call delay, and then return the value of 4 to the working register. Or else we go to check 4A to repeat the process. The same is true with check 7. Now, why is this check 1, check 4, check 7? It's because of this keys 1, 4, and 7. Same is true for key number 7. If it is clear, which is located, if port B is clear, port B5 is clear, it's where key number 7 of the keypad is located. We call delay and then go to check 7A to see if it is set. If it is set, then we call delay and then return the value of 7 to the working register. What is check 11? Check 11 is this asterisk, okay? And this is 12, the number sign. Now the same process is going on for the other columns. So the same, if it's clear, we call delay, or else we go to column 2. Go to column 2. It is clear, we go check 11A, and check if it is, then check it, and call delay, then check if it is set, we call delay again and return the value of 11 to the working register, and then we go to column 2. However, if check 11 is already clear, we go to column 2, which is the next column, which consists of 2 2, 5, 8, and 0. So the same process is going on with the first column. So same codes there, till we go to column 3. And after the subroutine, we go now to the configuration section. We start now the program. We are now going to turn to bank 1, so that's why there is BSF status 5, and then we make port A as output. Then move the value of working register to trace A, and then we'll have move LWB 11111000, because why is this? Because we're using this as our output. We're using this, and then move LWB 11111000, then move the value of the working register to trace B. Why 000? Because we are using this, the 3 pins. These are the 3 to the least significant bit, 0, 1, and 2. So 000. This is pin 0, pin 1, pin 0, pin 1, pin 2, and the rest is it. And then we move this to trace B, and then we move the value from trace B to B 000111. Because since it is input, we're using we're using input. However, we move on further. We move the value of the working register is B 000111 to optional _R. Then we'll now clear the status, meaning we return to bank 0, then clear both port A and port B. Then here we start our program. Now I have already fixed some numbers as security codes. First, for the red LED, I chose 1, 2, 3, and then for the yellow, I chose 4, 5, 6, and for the green, 7, 8, 9. We have for each LED, after assigning the numbers, we move the 1 value to the working register, then move it to num1, then 2 to num2, then 3 to num3. Then we call begin, and then begin calls scan no operation, and then we scan the keypad, meaning if we will scan and check whether we are entering the correct numbers. So this is loop 1 first, the first 3 batches of numbers. Loop 1 sub WF num1W. If the BTFSS status 0 bit, it tells us if the number really is 1. If yes, we call scan and get the second number, or else go to begin, back to start, until same process. If we got the second number correct, proceed. Then if we get the third number, if we got all the 3 first numbers correct, then port A0, meaning the red LED will turn on, and then after that we go to the yellow LED. The same process. If we enter the second batch of 3 numbers, 4, 5, 6 correctly, then the yellow LED will turn on. Yellow LED will turn on, and then we go to green, the green LED. The same process, if we entered 789 correctly, then the green LED will turn on, and then if that turns on, we can now click 0. The same process we read in how we assign numbers. It's the same with 0. 0 is functions as an enter key, and then it will turn off the green LED. Then we're good, and that means we're good to go. We can enter. So we have correctly entered the security code. We entered 0, then we turn off green LED. And that's how we end the program. Now, if we build this, go choose, go upload the hex file, and then start simulating, and then we start entering the numbers. If we correctly enter 1, 2, 3, the red LED will turn on. 1, 2, 3, it turned on. Next, 4, 5, 6, yellow LED turns on. 7, 8, 9, green LED turns on. Since they all turned on, we can now enter by clicking 0. That means we're good to go. That's our final project. Thank you.